Looks to be okay. Oh, it's 12.
Turn those lights off. Thank you. But everybody can see the board. It's our great pleasure to welcome Professor Gupta to the Water Research Laboratory today, and his wife Phraya also is here, so welcome to you both. And the Professor has worked at the Asian Institute of Technology in Bangkok, Thailand for many years. He's still Emeritus Professor there, as I understand.
Yes.
Received a number of international awards in groundwater management, and has most recently been doing some work in Europe, and he offered kindly to come and give us a seminar on his work and talk about the things he's been doing. They're both now living here in Sydney, and so there might be potential for collaboration with Water Research Laboratory or our friends at Kensington as well. So,
thank you. Thank you very much, Bill, for your nice introduction.
Exciting, there's other people now.
Oh. Okay, my talk today will be on, as you have already seen the announcement, I will talk about the groundwater development in Bangkok area. Why I picked it up? Because this is the major activity which I have been doing for the last 30 years. Till my coming over here, I was associated with the Department of Groundwater Resources in the Ministry of Natural Resources and Environment under the Thai government. So initially I have worked in collaboration with them when I was at AIT, and after retirement since 2007, I was working as an advisor to the Director General in the capacity of helping them in addressing different issues with respect to groundwater management in Bangkok area. So I would like to share with you this case. So in my presentation, I'll give you a little bit of background and an overview of the system. And I'll give you a chronology of a comprehensive investigation which we started in the year 1978. And it's still going on. And in the process of doing that investigation, we have to come up with regulatory measures, with the implementation of policies through government cabinet resolutions and so forth. And then at this stage, we are assessing the impact of measures. And also one of the important aspects which we didn't look into is on the water quality aspect. It was not a major concern. The concern was slightly different from that, which you will see, and then I will have some concluding remarks. So with regard to background, I think this is very common in many big cities which are near to the coast. Either surface water is not abundantly available because of use in the upper catchment. So naturally, groundwater becomes the alternative source of water, and that's what happened in Bangkok. So groundwater has been extensively developed over the years, and of course, whenever the groundwater development takes place, you just start drilling wells, and as the water is coming out, you don't bother much. You get water as much as you can, and that's what happened there. Consequently, with the increase of pumpage, we have to look into its consequences, and that's what we try to look into, and we try to bring in some regulatory measures. But again, I would like to tell you that there is a lack of attention given to the quality aspect, and this is the area where all the future thrust will be, looking into the quality aspect, particularly chloride contamination, and to see how the regulatory measures can help that. So, to give you a little bit of area where we are referring to, I think most of you have traveled to Thailand. It's a very popular touristic place. So this Bangkok is the capital city of Thailand, right over here. I don't know whether this one works. Does it work? No. No. Okay. Never mind. My finger will work. So we have this. This is the capital city over here. We call it in the Chao Basin. Chao Basin is the largest river basin in Thailand. In 2011 flooding, this was the major river which created the problem. But that is a different issue. Again, it is nothing to do with climate change, nothing to do with anything. It is the management issue, the way the dams were operated. Anyhow, this study area is having a core Bangkok city and with few adjoining provinces. There are 1, 2, 3, 4, 5, and 6. There are 6, sorry, this one. 1, 2, 3, 4, 5, and 6. And this is the center of Bangkok. So that's what we call the greater Bangkok area. You can say suburban area, and then we have also development beyond the suburban area. And these areas have developed quite extensively nowadays. So looking into the socio-economic growth, just to give you a glimpse of that, that's the population growth in the city. And if you look into Bangkok city, it's about 7 million population, 8 million, but if you include suburbs and exurbs, which is the extended residential area beyond the suburban area, it goes almost near to 15 million. And if you look into the associated aspect of economic growth, you look at higher level of living, the standards of living of the Bangkok people have gone tremendously high and high over the years. Whereas the country's average is lying somewhere here. It's about $500, compared to that the Bangkok residents or households per month average income is over $1,000, which has grown over the years. At the same time, we have a lot of industrial growth in the areas. Over the last decade or so, the number of industries have doubled over the last decade or so. And this brought in a highest amount of local economy. So you cannot stop that. It will be growing certainly due to rapid urbanization, continual progress and development. As you see in the Bangkok core cities, it's about $9,000 per capita. That is the GDP, provincial product, gross provincial product. Whereas in an adjoining province, it is much higher than the Bangkok core city, and that is the industrial area, which is about $10,000 per capita. Including these aspects, what then have to be looked into? Of course, for meeting this socio-economic demand, certainly you need a basic water supply, which is reliable. Highly reliable water supply is very much needed. But normally, in those big cities, you will have a Metropolitan Water Works, which provides the water supply. So here also, the Metropolitan Water Authority provides the water supply for Bangkok and 3 adjoining provinces. So there are 6 adjoining provinces, but they are providing supply for 3 adjoining provinces in the late 70s. And the provincial water works, which is also a huge body of water supply. Sometimes they buy water from Metropolitan and they supply it to the province, because if they don't have index structures properly. And then we have the village piped water supply system, This is also partly surface water and partly groundwater. And then you have private water systems. So there are 4 options for supplying, and the reliability is very, very important. So what we look into is that Metropolitan Water Supply provides only 48% of its area of responsibility. That is, I'm talking about in late 70s, early 80s. So the remaining part of the population will heavily rely on groundwater. Metropolitan Water Works also use groundwater, but it's very limited. They mix it with surface water and supply it to the system. So the groundwater evidently came into the picture, and there was no regulation against pumping of groundwater. If you can drill well yourself, you can pump. There is no restriction at that time. So initially, people have their own wells, and luckily the city is sitting on a very thick, unconsolidated formation, very thick, going all the way up to 550 to 600 meters below ground surface. This is a cross-sectional view what you see on the top. That was the only sectional information we had in mid-70s when we started investigation. We rely everything on these cross-sectional data. And it indicates there are about 8 layers below the ground surface. These are all confined layers, and they are named according to the area where they were first identified. So that these these names are sometimes they are the name of the provinces where they are being identified, and they are going all the way up to 550-meter zone. Out of this, the first one, which is the most shallowest one, 50-meter zone, its water quality is very poor. And why it happened? It certainly, you might first think of leakage from the surface, but it is not. It is also that these sediments were developed in marine environment. And there are a lot of deposits, not only at these layers, but in deeper layers where you can find marine living body which are dead, of course, but you can, when you drill well, you can get all those bodies. Out of 8, these 3 are extensively used. And this is the best one among the 3 because it provides good quality water, and also quality is one thing, and also the rate at which you can withdraw water is also very important. Of course, there are wells going into deeper aquifer, but not for the domestic purpose, but for industries, because they can afford to drill wells, and industries are not permitted. I'm not talking about early days, now, are not permitted to withdraw from these layers. They can only withdraw from these layers. Why? There are reasons for that. I'll tell you later on. This gives you a little bit of historical information on how groundwater pumping increased over the years. This is 1954. The pumping rate, this is the pumping rate given in million cubic meter per year. Here it is almost hardly any. As you see, there is a steep rise. Here it's quite flat, but the steep rise happens here. In mid-70s to mid-80s, a heavy rate of increase of pumping. But what you see the changes here, this is when the measures were implemented. We have some reflections of impact on the system. But as a result of this continual increase in pumping, the groundwater level declined at 2 to 3 meters per year. As you see some of the observations, this is the 4 layers as I mentioned to you. First layer, this is the second, third, and fourth. One interesting thing you will see that reflection of response of these layers are identical. And this clearly indicates that the system is not permanently separated among the layers, but the layers are interconnected. And that makes it much more difficult to analyze a system because the interconnection is not uniform, it's heterogeneous. So that makes our starting point not to go into straight away into three-dimensional models as the mathematicians or the modelers try to do it. Whatever data they get, and the models are easily available nowadays, groundwater models. During 70s, it was not easily available. We had to write our program. So we started with the simple analytical programs. But now nobody thinks about those because the models are in the next door. So you can just use it. And that's what killed the whole system. So because of substantial groundwater pumping, you have associated consequences, which one of the important and critical thing happened is subsidence of the city. We had land subsidence, we had effects on buildings in the cities as well as in the suburbs. Now this is, and these two figures are coming from Asian Institute of Technology. This is where these are the dormitories and office buildings. And this Asian Institute of Technology was built here in 1973. And by 78, we have seen these problems. In 5 years' time, all the basements collapsed. The building stays because they are all piles. We had also problem with regard to existing wells because the wells were protruding. This is called the protrusion of wells. We had also problems with regard to water distribution system because the wells are deep, whereas wells connecting with the pump is sitting on the floor, on the ground surface. So the ground is subsiding, but the well is not subsiding at the same rate. So there is always a problem of connection between the wellhead and the pumps. And the connection, as you see here, by flexible pipe in order to take care of that. But this works for some time. Later on, you will have difficulties. This is the experience of flooding of an area for 3-4 months. This is not the flooding as we have in 2011. This is flooding from local rainfall. And the drainage system malfunction because of settlement. So this type of flooding is not happening nowadays from local rainfall because the drainage system has been improved, as also their levels are regularly being monitored. So you have effect on the drainage system and flooding, and then we have coastal erosions. So in order to address these problems, and the problems can be identified as continual drawdown, which brings in subsidence problem, and associated water quality, which is the chloride contamination. This is what, and this is very nice. You have a supermarket. In 73, there was no supermarket in Bangkok. Now there are millions of supermarkets in Bangkok. This is one of the very first supermarket. The steps going into the building and the building basement and the first step, there is always a gap. And they keep on putting in extra steps with different color. And each color stands for some duration of settlement. So this is also a visual observation of the measurements. Just to give you a glance of when it was noticed in 1960s. I was not involved at that time. I was involved when it was in 76. We conducted few studies. We tried to relate it with respect to pumping because the politicians were not convinced that groundwater pumping is creating the major problem. Because in order to carry out this investigation, we need substantial amount of fund. So we had to prepare the basic informations with some limited field data collected. So since 1978 up till now, I think this is 1 meter total drop is up to 2004. And 78 to 81, the rate of subsidence was between 5 to 10 centimeter per year in some areas. And from our investigation, we could easily show them that the subsiding areas coincide with groundwater depression zone. But the subsidence has not stopped. It is still happening, but at a very lower rate. Well, I'll skip this part because the chloride information which I have here on the slides, they are monitoring data which we collected along with the water level, but these are not so much investigated in details with respect to their source of contamination, with respect to how they are migrating. Some preliminary assessments were done, and that's what it was indicated in one of the studies conducted by JICA, Japanese International Cooperation Agencies, in 1995. They used simple advection analysis in order to find out how long it will take for certain contour values or certain front of saltwater to move inland from the shoreline. Here is your shoreline is over here. That's the river Chao coming down to the shoreline. As you see, in some areas, concentration is over 6,000 parts per million because this is along the coast. But in the inland areas also you'll find concentration above 7,000 milligram per liter. That's quite high. Again, this is related to some embedded saltwater body, which you call conduit water body. So these are the three layers indicating. So what is then we have to look into as a water professionals? Now I'm going a little bit away to what water professionals can help. And that's what our direction was initially, to go slowly into the direction of helping the decision makers or the planners to come up with proper management policy so that the resource can be maintained. Of course, it has to be used at the same time, but you cannot use beyond certain limit. So our approach was divided into several steps. First, we try to understand what is happening. So first 1 year or two we spend on understanding what is really happening with respect to analysis of the field data as well as with model studies, because we need to amplify that. So we have modeling investigation coupled with basic data, but this could be simple model in order to amplify what we observe and we expect to happen in future. We have to organize all the information in a way so that we can present it to the decision makers or the planners. We can write several articles, publish a lot of papers, but doesn't help for the planners. Planners need to see exactly on the basis of which he can make some decision. So we have to prepare in their language the material for them. So we have to evaluate this, and we got to have a good system of knowledge sharing and transfer. So for this project, it was a joint investigation by AIT along with government body, which is looking after the groundwater aspect, as well as with councils in different districts for using groundwater, as well as with the industrial department. And of course, you need to enter to measure things, so you have to take help of Royal Thai Survey Department in order to carry out all the monitoring aspect, because they have all the equipments. We do not have all the equipment, so we can take their help. So it was a joint investigation, I can say, by three groups. One is the academics, another is the body which will ultimately look into the management, another body is helping in collecting all the field informations. So where to start? So in order to do that, where to start? First you have to understand what is the geological stratification. As I showed you, we had only very simple information. That one you saw, the stratification, which is not enough, because the field data you have seen, all the levels are going in the same pattern, different layers. So we have to do a detailed data collection, and we come up with the first gross fence diagram. I'll say gross because based on very limited information. As you see, there are, these hatched ones are clay layers, and these are sand gravel layers, and they are not uniformly distributed over the whole area. Now this we prepared the first one at the end of 79, 80s, and that has been upgraded every 5 years, and now we have a three-dimensional geomorphological information of the whole catchment of the lower Chao River Basin. And this will be now used quite extensively to address the flood issues which you had in 2011. The second one is hydrogeological investigations, which I just talked about. And here we look into hydro part, that means look into the properties, physical properties of the formation, how the aquifer behave over the area. So we need to have pumping wells and monitoring wells. So by now we have about 150 monitoring wells over the Bangkok area. And each monitoring well is having 3 observations going to 3 different levels. So altogether you can say 450 monitoring points. They are going at 3 different depths for the 3 major aquifers being pumped. What is the next, particularly when we are referring to land subsidence? We need to know where is the compression happening, which layer is more compressible compared to other layer. So we have to find out the compression characteristics, compression of layer, and the land settlement. That means how much the land subsided at different locations. This is done by surface leveling. Compression characteristics done based on soil sampling, undisturbed soils, analyzed in the lab. And compression of layers also we have measured by compression indicators at different depths. Now this slide tells you this general information on subsidence. Now this is, as I said, we have 3 layers being pumped. So these are the 3 layers, and since you are pumping, you have a drawdown curve. That's the trough. In the vertical section also, if you have a pumping from this area is one of the highest, let's say, then your drawdown curve on the vertical direction also will be like this. Now on the right hand side is a simple evidence you get on land subsidence by visual observations. Just to let you know, suppose this is the original level of the ground surface, and you have a small hut sitting on it, and also you have a tall building, multi-story building, 20, 30 stories building sitting on it, and at the same time you have a groundwater wells which is going to a depth of less than 100 or 200 meters. Now of course this building is on piles. Of course this hut is not on pile. So as the land subsides, this hut also will go down along with the ground surface. So this is the present level of the ground surface of the subsidence, but the building will not go at the same rate as this hut. It will go at a lesser rate because there is a skin friction on the pile which will resist it's settling. Same with the wells, there is a skin friction which will resist its settling. So what you see, that the base of the building goes down a little bit and the ground surface is here. That's why in AIT's figure you see all the things are cracking, because this is the approach to the building need to be addressed to. So this D1, D2, these are what we say observed settlement. We observe. And that's why in early 70s or mid 70s, this observed settlement became very predominant. Many of the buildings collapsed. Many of the school building collapsed because old building of the school and the new building of the school, they are different. They are connected. But because of different settlement, the building doesn't function properly. So they have to close the school, do the repairing and all this. So this type of economic loss came into picture, so it becomes more predominant that this need to be addressed to. So that's how it happens in mid 70s. This became a critical issue. Now I have to skip maybe some of the slides as I need to go to the management. This slide indicates you a basic information for monitoring purpose. How you monitor with respect to water level, with respect to compression. As you see on the right hand side, you have a compression indicators going at different level, recorder. So the compression recorder will be over the certain thickness of the layer. So it will record how much that thickness change with time. Because as we pump water out, pore water pressure decreases. So the effective stress on the soil skeleton increases because the overburden pressure remains the same. And because of the effective stress increase, you get a compression both vertically as well as laterally. So this is to give you a glimpse of subsidence recorder, one of the stations. And you can see there is a difference between this picture, this and this. They are the same instrument, but what I can show you, you might have observed already, some of you, difference between the last one and the first one. There are two tubes. This is the outer ring and that's the inner one, inner tube. And this outer ring and the inner tube, they are at the same level. At least there is no difference. But here, the outer ring and the inner one, there is a difference. It has come out. You see the black part. This black part was hidden here. Now what is this black part indicates? This is the amount of subsidence, visual. We are recording their compression. Because this outer ring is sitting on the ground, whereas this inner tube going all the way up to certain depth, 100 meter, 150 or 200 meter. So this is going down and this one relatively coming up because it is sitting on that. Could be a hard rock, could be a hard sediment, but there is always skin friction on it. So it will be registered to subside. So this gives you a visual observation of observed subsidence. These are more into detail of typical compression curves for different types of soil. Compression is not an elastic process. It's not. It can compress, but its swelling may not be in the same rate depending on the composition of the soil. We have in Bangkok area, we have of course sandy soil. That's the sandy part. But you have also clay. And clay also, you have soft clay and stiff clay. But when you look into clay, if you have soft clay, they are repelling. Repelling means if you reduce or increase the water pressure, that will not swell back to the same extent as it was before. As you see, this is the draining curve and this is the swelling curve. This is for soft clay, whereas stiff clay is already hardened. So they will be more or less same. Sand, we can take more or less the same coefficient, and that coefficient we have to define the rate of change of compression parameter, because compression parameter which you use, they are not same over the whole range of applied pressure. So you have to define that. So this is much more complicated, and you have to do a total analysis of these informations. And that gives you some soil layer compression at different depth. As you see, this first one for 1 to 53 meter. The 1 to 53 meter depth zone, how it compressed over the year. That's the compression in millimeter on the left-hand scale. And that's in year 78, 79, 80. That's the time when you started investigation, detailed investigation. This is for the same location, that is 1 to 53, this is 1 to 10, and this is 10 to 53. So we bisect into shallow 10 meter and the deep 10 to 53. Now you see in 1 to 10, you see the compression and swelling happens. It compressed, then it swells back, compressed, because this is the soft clay part. Whereas in the deeper part, there is more or less, not at the same time swelling, but little bit changes happening, but there is a continual decrease or increase in compression. But here, overall remains more or less the same. So the contribution of this will be more, 10 to 53 meter to the subsidence or the land subsidence compared to the shallow layer. So that's how you have to identify which layers are to be addressed to. This is also the same. Good correlation between the compression indicator and surface leveling. Because surface leveling is done by Royal Thai Survey Department. This was observed by AIT and analyzed. So we try to superimpose the two things. And we found very good correlation of surface leveling data with 200 meter thickness compression. This is 1 to 194 meter. So that clearly indicates the first 200 meter is contributing extensively to the subsidence. So we have to address to the groundwater pumping in the first 200 meter. And then also we have to define the correlation coefficient between the compression and the pore water pressure drop. So these are coefficients are being defined based on undisturbed soil sample analysis. Now the land leveling is, as I say, it is done by Royal Thai Survey Department. There is a good network now. This is the final network, which is just released in 2013, last year. And we have not talked about how many wells are they pumping. What is the pumping rate? There was no record in 70s, no registration, nothing. So we had to carry out house-to-house survey using our university student with Thai government's declaration. We cannot go to house and ask for it. So it was announced by Thai government cabinet that there will be, during this period of 3 months, there will be house-to-house survey on groundwater use. So all households, public and private enterprise should cooperate. And in that process, ultimately, we come up with so many dots. These dots are indicating pumping wells. They were all private pumping wells, 10,000. We got in the year 1978, end of 1978. 10,000 pumping wells without any record. Now they have records. But at that time, there was no record. So you see, this is the second, third, and fourth. As I told, they are the most productive and extensively used aquifer. Deeper layers are less. So we organize all this data and put it into our tool. So we have to conduct some of analysis, that means amplification of these observations. So over the years we have developed the model, and why I say we have developed the model, initially we prepared our own model. So we have a groundwater flow model, and we have the consolidation model. And then now we have incorporated along with is the transport model. This is done by the department concerned, and one of the institute, many of the Thai national institute or universities are involved in that. And there are some other models which look into impact of land use planning on groundwater aspect. They look into economic aspects, so there are other model structures available. So this was the original schematization of the flow and consolidation model. So we have different layers, and of course these boundaries are defined based on hydrogeological information, and we have the piezometric pressure change correlated with compression and accumulated land subsidence. So that was the initial models. That's the flow equations, and the consolidation model is one-dimensional, and now it is transformed into two-dimensional, looking into lateral one, but initially it was one-dimensional, looking into vertical consolidation. Now the model was developed in stages. We started with very simple two-dimensional model, single aquifer model in 78, 79. That is our own written. Then we have a quasi three-dimensional multi-aquifer model 82 to 84. So this is the period we have the major project intervention. On the basis of outcome of these study, all the measures were implemented, and subsequently these are being checked and improved. So now they have a fully three-dimensional multi-layer model which is being used since 1992. This was the initial part. I don't think I'll need to go through them. This is a traditional way of carrying on the calibration of the model with flow as well as with consolidation. So that's the first step which was taken based on observation and extension. That means amplification. We identify three critical areas over the Bangkok and adjoining provinces. The first one is the most critical zone where the subsidence rate was more than 10 centimeter per year and water level was declining. The yellow part was intermediate, that is 5 to 10 centimeter, and the green part is less than 5 centimeter per year. So these critical zones were identified. That means there were regulation implemented for new wells and also regulation implemented for existing wells, because if these areas are already supplied by surface water system, then for the next 5 years or so, groundwater pumping needs to be tapered. That means you have to switch over from groundwater to surface water. Of course, you will not, people will not do it willingly. You cannot force. It's difficult. So there has to be some incentive. So that has to be built into the management process. So the regulatory measures was instituted by what we call Department of Groundwater Resources. And it's based on, for the public to have an idea of what is happening, is based on monitoring data. Of course, behind the model study is there. But when we talk to the public or in our public enterprise, we bring in observations, facts and figures. The moment we bring in model, it doesn't work because we have to be a bit diplomatic to work with them. So we have a monitoring and modeling carrying on. We had initially 117, now it is 150. And regular monitoring started in 73-8, and the modeling studies carrying on every 4 to 5 years. The first regulation brought in, Act were prepared in 77, but it was implemented in 78, 80s. There were a lot of amendments, and as I say, critical zone being defined, and groundwater was free. People were not paying for it, but charges being introduced in 84. So this summarizes a little bit of policies and regulations. I briefly go through them quickly. 69 is the subsidence given public attention, and it took about 10 years to start with the work, about 7 years to start with the project. 78, we enforced the Groundwater Act. That means licensing for groundwater activities. Of course, groundwater is considered as public, in the public domain, so you have the right to pump, but you have to get permission to pump. So that was brought in simply because you are being advised at what rate you should pump, and you are being advised where to introduce the pumping. So that is the responsibility of the groundwater department. So 83 critical zone identified, and 84 the groundwater tariff was almost zero, 3.3 cent per cubic meter it was imposed in 84. Act was amended in 92. In 94 tariff was increased to 3.5. It is still quite nominal, but you can see this is 3.5 times what they were paying in 84. Now these were for the Bangkok city as well as adjoining provinces. With years their influence zone was expanded, and in 2000 the tariff was again started increasing from 3.5 to 8.25 Thai baht, which is about 12 cent to 28 cent per cubic meter, and this is again stepwise. So every year certain step increase. Then what was brought in was for implementing proper measures as well as for assisting the major users of groundwater. We need to identify additional fund. And if you are going to use groundwater from these critical areas, of course you have to implement certain measures, whether these measures is directly for groundwater or other associated, for building construction, for flooding, for drainage system. Since you are the one who is using groundwater, you have to pay for that also. So that's what conservation or preservation charge was brought in. Of course, it is not easily done overnight. You have to have a lot of discussions, understanding, and deliberation. So this conservation charge was brought in 2004. Within a 3 years period, it was gradually increased, exactly from 1 to 8.5 or 3.3 cent to 27 cent. But during this period, from 2006, that's the time when I joined the department as the advisors, and we had a lot of deliberation with the group who are paying these monies, but they want to get the benefit out of it also. So we help them in switching over from groundwater use to surface water use, but they have to have their own implementation. So we help them financially in introducing all those implementation based on the fund we generated from this preservation charge. So this fund is being used to help them. And now this charge has been reduced from this level to this level. is almost half now. And this happened in only 2013. So this gives you briefly overall aspects of the implementation, what happened. And these are the 2 points where the Groundwater Act was introduced and the cabinet resolution which brought in. So you see, this is the total abstraction which went on, then it started reducing. And of course, that's the groundwater charge. And this is the groundwater preservation charge which brought in. Now as you see, supply of Metropolitan Water Works was much lower. They have increased their supply in order to curtail the groundwater. So this is because people need water. Without water, you cannot survive. So groundwater body as well as surface water body has to work together. So there is a groundwater committee which is jointly coordinated by Department of Groundwater and the surface water. So I'm not going through these acts. I just would like to show you the results. The first critical zone was defined in 1985, 83 actually, 84 implemented. And this zone is modified now, but the rate of subsidence has tremendously gone down. Critical zone 1 was more than 5 centimeter, now it is more than 3 centimeter per year. Critical zone 2 was 5 to 10 centimeter, now it is 1 to 3 centimeter, and critical zone 3 is less than 1 centimeter per year. So you modify and implement it with respect to the second critical zone. That's the comparison between the two. As you see, the red area is still heavily regulated because this is the central Bangkok, the most commercial and economic zone. So you can have the whole country flooded, but this cannot flood. This area is very important. So 2011 flooding outside Bangkok was flooded, but this was not flooded. This was working functionally, everything going on effectively. So the impact of measures, reduced groundwater abstraction. Now there are about 4,000 licenses, around 3,000 owners. Abstraction is now about 300,000 cubic meter per day. It went up to 2.5 million cubic meter per day, but now it has come down to 300,000. And largest industrial users, they have moved out of the critical zone. The last mover which is moved out of the critical zone is the beer factories, because they use a lot of water. And there is at the center of the city, there's the oldest beer factory, which has stopped. Reduction in land subsidence rate, but there is unclear indication of improvement on groundwater quality, because particularly not much attention gone into that, because more attention was going into land subsidence. But Department of Groundwater Resources is now taking steps. They think that significant improvements in chloride contamination remains to be seen. They want to look into that, and they want to put their effort extensively on that area. So this figure shows you the impact. Overall pumping, total abstraction is this line. As you see, after implementing in 84, 85, groundwater pumping went down. And again, it started increasing because of drought season. But in 2000, it has then tapered off. And this shows the groundwater level going down up to year 2000 and then started recovering. These are at different depths in different locations, but all showing a trough improving in the pressure level. And this is also the zone of subsidence. large zone were subsiding in 1997, different rate. In 2002 or 2001, you see the large zones are not there, but they are small zones, but scattered over areas, and the rate has also gone down. Same with 2002 and 2003. The rates are much lower, 1 to 2, 2 to 3, and 3 to 5 centimeter, but there it was near to 10 centimeter. So that's a reduction of land subsidence rate in critical zones, but apparent increase in other areas. Impact of measures on quality. As you see, these are some samples. We try to look into their quality information for chloride, TDS, and iron in 96 and 2006. In 10 years, what are the changes? With different wells being sampled, there with parameters over the limit and with parameters above the limit of percentage of the wells. We observed about 65%, 70% of the wells being screened were over the limit, and by 2006 it shows some increase of the wells showing indication of increase. So that's the for 3 layers. And in aerial distribution, you can see the 2 things. This is in 1992 and this is in 2010. This I just got last week from the department. So you see everything is in Thai. It's not yet translated. All are written in Thai. So you see the zones where salinity concentration is high is near to the coast and river mouth. But you have on the inland areas high level of concentration, and that's what we need to investigate. Okay, so that's roughly what I'd like to mention. So in my concluding remark, we need to bring these 2 things together. This is very important. Why in groundwater this is important? The groundwater department starts with drilling of wells. So you have the expertise of drilling. You have the expertise of reading the logs. You have the expertise of analyzing pumping data. You have the expertise of all this. But when it comes to management, we have to change the side of the coin. So you need a lot of capacity development for the institution, because you cannot kick them out, your drillers and all this, but you can use them with proper training, proper innovative ideas. You can bring them to help in our management aspect, because we need to use the information which you gather from the field, analyze it, and get the feedback for our decision making. So we need to strengthen this part, which is the technical part which you have, which will strengthen, of course, by linking authorities with the institutions, engineering institution and research institution. You can carry out this part quite effectively, but at the same time we have to bring the other domain of the institutional capacity to be highly improved with human resources. So this is what is very much needed, and this is by concluding, I will show you some of the slides of the stakeholders meeting we have. Very often every year we have the meeting with all the groundwater users, researchers. So there are 50% would be from the universities, institutions, and 50% will be the groundwater users. And this will be called 1 half day or 1 full day meeting. This is a regular phenomena, and it is not a very serious meeting, but a very useful meeting, because you get many things done through this meeting. If you make it very serious, then thing doesn't work. So you bring in some important elements to talk about, to discuss about the policy which are in practice, whether it is working, why it is not working, how to be improved. So that type of dialogue can be carried out. So I show you some of the important things which came out. We have a lot of illegal groundwater use, and this came out through dialogue. Because when people are asked to switch off their pump, they will say, well, I need water, but there are many who are pumping and they are not registered. So that way you know who are doing. And this is one of the areas where they are tapping a lot nowadays. Effect of limiting groundwater use on economy. This is very important. Because if we curtail supply to industry, of course it will affect the economy. It's also very important. So various aspects has to be looked into in coherence. So we have regulatory measures, we have economic measures, but these two measures need to be supported by technical background, fully technical background, so that you can implement in practice. So these are some of the functions which are currently being looked into, and this is what I talk about, capacity building of government personnel. This is where I was involved for the last 4 or 5 years, how to improve this, looking into its database, awareness campaign, bringing in different research activity and feedback to the Groundwater Act. So this is where I was very much involved over the last 4 or 5 years. Finally, on groundwater quality, something has to be done. And there is a need for identification of areas where quality is being deteriorating substantially, and identification of why it is happening. Because you cannot say it is surface pollution, because they are pumping from 100, 150, 200 meter depth. So why it is happening, we need to identify. So that's why we need sufficient fund to support these activities. So this fund which is generated from contribution from the industries will be used for this purpose. So with this I would like to conclude. Thank you very much for your attention, and I welcome some questions and answers. I told you 1 hour. I told you 1 hour.
Some people may need to return to work. Those who are able to stay, perhaps we'll have some questions. So, questions, please.
Yes, sir.
Just to put it into perspective, the Metropolitan Water Authority.
Metropolitan Water Authority. Yes.
What is their charge for water delivered to the household in baht per cubic metre?
Oh, now it is about 9 baht per cubic meter.
So the groundwater cost, the licensing cost as well as usage, the groundwater is comparable.
Yes, it's more actually, 8.5 plus 8.5. Now it is 8.5 plus 4.5.
But in the past there was no charge.
No charge at all. Now, why they want to use groundwater? Because surface water you use chlorine for chlorination purpose. So industries, they don't like it. It affects their usage of water in the industrial process. So industries will prefer groundwater all the time. So that's why they are now pumping from deeper wells. Now if they go to deeper wells, then they are not paying that conservation. But if you are pumping from these 3 layers, you have to pay. So these are contributing to the drop. Yes, 2 hands. Ladies first.
I'm just wondering how likely it is that maybe well integrity might be a problem causing your contamination. If you've had this massive density of wells drilled without any regulation connecting different layers of the aquifer, is that likely to have been a big
there is one being identified regarding to well integrity is there are many abandoned wells. And the abandoned wells, if you don't seal it properly, they contribute a lot. So that's why I said this is a very large area to work on it.
And decommissioning of your old wells.
Yes, yes. So this has to be looked into. But the problem is you need funding. So what we are trying to use that groundwater fund, which is it's in millions of dollars now. That fund is quite large. But again, to use the fund, you need the government permission. So this is under government control. And so, well, some project will come up because after this funding, now for the lower Chao Phraya Basin, there is a water management project is going to be commissioned. It has to start. And maybe you know about e-water. Anyone know about e-water? E-water may be involved in that project. And we'll see. In that one, the groundwater aspect will be integrated and look into this quality aspect. That's very important. As you see, there are a lot of cones of salt contamination. Cones means, concentric circle of concentration of chloride. So that means there has to be some source. Otherwise, how these cones generate? So it could be vertical leakage from the top or the layer bottom. Could be through uncapped wells or could be through formation linkages. There is no clay layer much, or clay percentage may be very low. So the leakage takes place at a higher rate. Yes, sir.
Yeah, I'm wondering, it seems like there's a connection between putting a cost on groundwater usage, this reduction in groundwater usage, etc. We see similar things in, for example, congestion charging or putting a price on carbon. But we know also what's the politics with these costs or negative aspects. So how does this go down there, increasing suddenly the price for groundwater by 3.5 times? So what do people do? Because economy might have gone into
this 1 to 3.5 going up to 8.5, as you see. If you use water from surface, you have to pay at that rate anyway. Now at this time, when it was not introduced, you were using groundwater freely. So psychologically, you have to bring this in everybody's mind that if your next door neighbor who is using metropolitan water and he or she is paying at 1 or 3.5 or 8.5 baht per cubic meter, then I am getting it freely. Is it logical? So I may have to pay also, because water is water, whether it is coming from surface or underground. So there was a lot of debate on this. But this is the way you have to bring this in together. But that's why I say they have a very good group of people who work together. It depends on who runs the show and who are in the show business. So it depends on many factors. So when it worked that way, it functions well. But you have to bring in this type of thinking in the mind of water users, because I'm using freely. There's no charge. But now government comes and tells me, oh, you have to pay because your next door also pays. So that's how the things gradually roll on. Now you see the charge has been reduced on this compensation. This is also rolled on because there were a lot of objections. In the last meeting of 2006 or 7, they were furious, industrial groups. They were raising these issues. So they have changed it. They have reduced the prices. So there are, but it's not an easy dice. You have to do a lot of work. They are good in that. Thais are good in lobbying, talking, playing golf together. It keeps very well of doing things. Many of the business done like that. Yes.
Just another question. Is there any other chemical constituents that are of concern other than just the chloride?
Iron and manganese. Yes, Fe and Mn. Yeah.
And does the modelling show that they may also be increasing?
They are already increasing. They are.
So if they get to a certain level, the public may decide that the Metropolitan Water
Oh yes,
is safer.
yes. If it makes a lot of problems in their daily usage, so they will change.
I suppose arsenic will come to play as well.
Not so much in this. Not so much in this area. Arsenic is more in the south, where the minings are, not in the central plain.
Well, thank you very much, Professor Gupta. Thank you.
Thank you very much. Thanks a lot.